This video, we're going to calculate the compound interest for um, we're going to calculate the accumulated balance for a investment or loan that is going to compound more than one time a year. These are all going to be investments because they say deposits here. So I'm going to show you how to do it by hand with the accumulated value formula. Again, that is A equals P times 1 plus R over N to the NT. The new thing that we're going to get is that N is going to be a number that's not 1 here. It's going to be the number of times the number of compounding periods per year. So in this case, we're going to have, in the first example, we're going to have the principal is 19,000 times 1 plus, so our R is 2%, and that 2% is going to be divided up twice because it says semi-annually, raised to the 2 times 5 is the number of times that the interest is going to be compounded, 10 times total in this 5-year period. And we're going to see that the amount of the investment after that period is going to be $20,987.82. Now let me show you a tool that's on most of your graphing calculators, maybe not all of them, but it should come on all the TI-84s. You should have a finance app here, and you should have a TVM solver. So N is going to be this total number of payments. It's going to be NT. So we just said that that's going to be the 2 times the 5. The interest rate is 2%. Present value is $19,000. We're not going to have monthly payments. We're going to have 2 cycles per year, and we're going to come over the future value here, and we're going to say alpha solve, and we get our answer. This sign for this, don't worry about that. It's always going to come opposite of the present value here, that it assumes that you are pulling money out, that it's a positive to you. So you're going to have a future value of the account that's going to be negative. If I wanted to say that I was putting money into the account, then I could have come up here and said that I was taking money out of my pocket right now to put into the account, and it would come up with a future value of the account that was positive. But those two things are always opposite signs to the calculator. So you're looking at the number, not necessarily the sign. I'm not going to keep using that tool because not everybody has that, and teachers don't always want you to do that, but I wanted to show that to you as a tool for how you can check your answer on, especially on these homework problems. So let's go ahead and do $1,200, 1 plus 4%, and it's compounded quarterly, so that's going to be divided by 4 raised to the 4 times 2 is going to be $1,299.43. Have $8,430 deposited. 1 plus 4% compounded semi-annually for 8 years is going to be $11,572.58. $5,500 at 4% again. This time it's compounded monthly, and it's for 6 years. We come up with a value of $6,989.08. Now we have $3,000 on deposit that is compounded monthly at 3% for 6 years. And that gives us $3,590.85. Around to the nearest cent. And for our last problem in this section, we're going to put $7,000 on deposit at an interest rate of 3%. That is compounded, interest rate of 4%. It's compounded daily. So we're going to use the banker's rule here, and we're going to use 360 days compounding periods in a year, raised to the 360th times 5. Bankers use 12 30-day months and say that there's 360 days in the year, even though we know that there's 365 or maybe more with leap year. But the book is going to tell us to use the banker's rule in this situation and use 360 when we compound daily. It's going to be $8,549.72. All right. Come back next time and we'll talk about how to calculate APY, which is annual percentage yield that has to do with investments like stocks and bonds.